If you are plotting out era5 land rainfall reanalysis data and you're thinking, these numbers look way too high, I have a fix for you. Feel free to pause this video if I'm moving through the code too quickly. Let's show you the problem that may be similar to the problem that you're having. Recently, I downloaded some era5 land data from the Copernicus website. Using Google Colab and Xarray, I set up a few variables and then changed the units of precipitation to inches. Then, in this block of code, I queried the data using starting and ending dates to capture the remnants of Hurricane Helene, which occurred generally from September 24th to September 28th, and I plotted this around the North Carolina area. I ended up with a plot like this, and you could see the bright areas of yellow showing rainfall amounts during that storm of around 160 inches. Now, Hurricane Helene was a devastating storm and a huge rainstorm, but it was not this big, so I know that something is wrong. And these numbers are way off. If we actually look at this map put together by NOAA for rainfall totals during Hurricane Helene, you could see a lot of those maximum rainfall amounts were around 12 inches, not 160 inches. Although I should point out there were some individual weather stations within this 12 plus inch swath that measured around 30 inches of total rainfall during that tragic storm. Now back to our map that is way too high with those rainfall totals. Let's scroll down and show you how to fix this. era5-land does something really weird when you ask for precipitation totals. To keep this very simple, let's just focus on how it gets 1 hour of data. If I ask for, say, the 1 hour rainfall total at 3 UTC on September 24th, instead of giving me that 1 hour total, it gives me all the rainfall added up from the 0 UTC hour up to that third hour. And then it does this iteratively, so you end up with rainfall totals that are way too high for the entire storm. But that's okay, we can fix this. And we're going to start with this method right here. So in this method here, let's think of the example of trying to get the 1 hour precipitation total for 18 UTC. We know that era5 land data will try to return the rainfall totals from 0 to 18 UTC. So like 18 hours of rainfall data. We don't want that. So to navigate through this, we're going to take the 0 to 18 UCT rainfall totals and also the 0 to 17 UTC rainfall totals. That's what those two lines of code I just highlighted are doing. Of course, if we're just getting the rainfall data at 1 UTC, well then we don't have this problem. That's why this conditional is here in this part of the code. And what we end up returning is the 1 hour rainfall total at 18 UTC. Another method that will help us navigate this issue is this method called date range that I'm highlighting right here. This will help us increment date time ranges 1 hour at a time. And that's what this method does right here that I'm highlighting. It takes a start date time and an end date time. It then uses this method called date range. Remember, that's the method I just showed you to help us loop through the date time. And then for each hour, it's going to use this method, the one that I just showed you that I built. And this is going to get that rainfall, 1 hour rainfall totals for each hour. It's then going to add all of those hours up and then return our grand total for Hurricane Helene. Just to recap this method, which loops through date time, is going to call on our two previous methods that I showed you before, date range, and then get hourly precip total. Let's finally put this method into action. So we're going to call on the main method right here and give it the start time and the end time from Hurricane Helene. We scroll down to the plot and there we go. Now our numbers look much more reasonable.